Okay, hello everyone. Okay, YouTube says I'm live. Is working. Great. Okay, that seems to work. Is everyone already here? I hope so. Yeah, I see someone is live. I think I will close this browser tab because it's being confusing to my internet. Well, where are you? Add here. I'm live now. Actually, you can add. Yes. I hope everyone can hear me properly, and I hope the sound is less choppy than it was last time. Please let me know because I have some filters that I can tweak. So has everyone gotten their coffee? Please do use the chat to reach me. Chat on YouTube. Presenting things. Okay, so I have no idea how I can see how many people are watching this. I see 18 people are online. Yeah, so hopefully they'll increase to the rest of the group in a few minutes. Of course, I said that we would start at 45. So for now, all you're getting is me and coffee. What is the delay on this channel? Okay, so roughly 5 seconds. You see that I have a super high-tech setup. So I hope everyone is doing well. I hope that everyone was able to do things. I see Lean is having some trouble. Yeah, I do think that to type stuff on YouTube, you need to be logged in on YouTube. If you don't want to create an account there, that's fine, of course, if you don't want to sponsor the corporate Google overlords. But yeah, I need to use something to chat with people. And yeah, Lean says that she is logged in on Discord. Okay, I have no idea how that works. Maybe you can ask someone to relay a question once that becomes relevant. I will close Discord, or well, at least hide the windows soon, because I need to manage my my streaming software, and it's hard enough with the YouTube live window, YouTube chat window in the corner, and Discord is a bit big to also watch. I thought that channel might be useful if you want to ask something amongst yourselves or something, the way you would usually do in the back of a lecture room. But yeah, I don't know how to do stuff. What time is it? We will be starting soon, I think. We have 29 people online. And that does not seem to be everyone who signed up, but that is their problem. Yeah. Yes, I will put this stream online. YouTube will do that automatically, but I will make sure to also post the link on the Brightspace of Hacking in C, and maybe we can also put it in the event description of the Thalia event, or I could send it over email. I mean, everyone has it. I will also be making the slides available. They will probably be useful as a bit of a cheat sheet for some people. And yeah, I think that's we also yeah, if you have any questions, they will also be able to be answered. I think I'll be doing a bit of Q&A if people want that at the end. Okay, so I think that most people who wanted to join have gotten the chance to do so. Oh, someone dropped out again. I think that is their loss. I cannot fix everyone's internet. Okay, so let's get started. There we go. So yeah, this is the Linux workshop for as a prequel to Hacking in C. It's not necessary if you want to do Hacking in C to also be there for this workshop. But I hope that, especially for those people who are used to clicking buttons on Windows, that it will be helpful as a first introduction to how you could do stuff on the command line, and thus give you a bit of a running start into Hacking in C. Why we are doing this online, of course, instead of in person is quite obvious. You must have been living on a very, very large rock if you've missed it, because I'm now an influencer, and working from home on YouTube is the new thing these days. And the university said that we will be doing this until June 1st at the earliest. They are sent around an email today saying that also during the next quarter, at least until June 1st, everything on campus will not be on campus, but online instead. So I imagine that for Hacking in C, which I will be teaching in the next quarter, that we will also be doing this online, much in the same way as we are doing this right now, slightly mirroring what Paul van Albel has been doing in object-oriented programming. So doing tutorials via Discord and screen sharing, and doing the lectures either via YouTube or via Twitch. I'm trying out YouTube now because Twitch has a bit of a high meme factor, which I might... I thought was not maybe the most conducive to do this. And yeah, Todd asked a question saying that might be changed though. No, what is That exactly. There's a bit of a delay in this monologue versus it reaching you and then you typing the answer. So if Todd can clarify regarding the online teaching. As far as I'm aware, the latest is that the university said that until June 1st. So it used to be April 10. So after the exam week, it was still unclear what would happen. But as far as I am aware, I got the same email probably that everyone got, is that we will do lectures online until June 1st. Maybe that will be changed if Corona magically disappears, which would be nice if that happens, but I don't think so. And there's also, of course, the fact that a lot of people, some of your fellow students who are not Dutch might have gone home to, say, Germany or wherever, and it might not be the easiest for them to also to get back here if the university just decides to open up. So I'm not sure how exactly that will all go. Yeah, with that, I think we should just, I mean, I also don't know a lot at this point. We will figure this out as we go along, and we will presumably, I will be sending emails whenever I know more. Also, because obviously not everyone who is registered for Hacking and C, which is 220 odd people right now, will be are obviously not all watching this video. So I will need to send around emails anyway. So where do I have my slides? There. Getting around on the command line. So I am Tom Wiggers, as you might have seen. I am a PhD candidate with digital security. That means that I do research as a PhD candidate, and specifically my research is into applying post-quantum cryptography. Specifically in recent months, I have been looking into how you could do TLS in a post-quantum way more efficiently than just replacing everything with post-quantum primitives. Very interesting. Ask me questions about that later or at some other point. I am supervised by Peter Swabe, who is also the normal teacher of Hacking in C, but I'm taking that over next quarter because Peter is on sabbatical. So he was hiding out in Portugal trying to learn stuff about formal verifying source code or something along those lines, and not being bothered with teaching and management and all that stuff that really helps. So that was what he was doing. And yeah, you can find me online on tomwiggers.nl. The YouTube stuff would ask me now to say, please like and subscribe and click the bell icon. You cannot find me on Instagram, but other than that, my website is usually fine. What we are going to be talking about today is Linux, and yeah, I will be introducing some of the very briefly the core things that what is Linux. Then I will show you a bit how to get around on a command line and showcase a bunch of common commands. Then we have a very brief exercise, and then I will show you a bunch of I/O special things that you can do in a command line, input redirection, output redirection, which you will find useful for hacking in C. Again, the slides will be available, so don't bother taking notes. You can look that up at that time. And a few small system admin things, considering you're now running your own VM instead of using a CNCZ administered computer. And finally, we will briefly try to cover exiting Vim. Linux. So Linux is a kernel. And what does that mean? That is a thing that interacts with hardware. So it's really only the very core part of the operating system. And it his main thing is interacting with hardware, making sure my webcam reaches you, making sure that my display is being driven. And to do that, it also does stuff like access control, so it's maintaining separation between users and between processes. A lot of those core operating system things, but it doesn't do much on its own. It provides a sort of programming interface for a bunch of other things, but yeah, it doesn't do much itself. And then there's also this other side of how things run on your computer, and that is user space, and that's basically anything that's outside of the kernel. They are subject to whatever the kernel imposes on those applications as rules, so that they can't, program A cannot talk to program B that's run by another user or something. And that contains all of these user utilities, like, for example, bash, ls, gedit, vim, factorio, what you can come up with. But also many system admin or services are in the user space of things. They talk to the kernel through APIs, but they themselves are in user space, and then either get the kernel to do stuff for them, or they implement stuff themselves. You might think of systemd, sudo, or passwords as also, that's really in the user space. You also have all of this graphic stuff that you see. So I am running some environment that is showing me my slides right now, and there's the broadcasting software, but also the window manager, the stuff that draws those boxes around your Chrome window, where you have this X in the corner where you can close it. That's also still in user space, so that the kernel does not manage all of that stuff. It provides through display drivers, etc., a way for these programs to draw stuff on the screen, but doing that stuff, the drawing, etc., is also not in the kernel. So that means that the kernel is really quite small. And in this case, we are talking about Linux, so it's a Linux kernel. Windows also has one. It's a lot bigger in Windows, I imagine, but yeah, it's also very hard in Windows to see where Windows stops and begins. But yeah, Linux kernel is a small piece of software that basically runs your computer, and it does all sorts of system management, access control, drivers, etc. And it's being built by this guy, Linus Torvalds. It's quite clear that he used part of his name to come up with the name Linux. And yeah, he mainly deals with hardware, and I have a nice video about that. Wait, of course, then I need to switch to
exception rather than the rule. And I'm also happy to very publicly point out that NVIDIA has been one of the worst trouble spots we've had with hardware manufacturers. And that is really sad, because NVIDIA tries to sell chips, a lot of chips, into the Android market. And NVIDIA has been the single worst company we've ever dealt with. So NVIDIA, fuck you.
yes, so
making some friends there.
That is Linus Torvalds, and he is really dealing with this hardware, and then he also has all of these companies that don't want to work with supporting open source, and that makes him very frustrated. On the user space side, there is GNU or GNU. They make all of these programs like your C compiler, GCC. They made Emacs, which is some editor, core utils, which is all sorts of core utilities. They make also the GNU public license, which you might have seen on a bunch of programs that you installed, a graphics toolkit, GNU PG for encryption, a bash, which is a shell we'll be using later. All of these, many of these user space utilities are in the GNU project. It's a whole umbrella organization running a bunch of things, and it's used to be run by this guy, Richard Stallman, and he wants you to call it your Linux distribution a GNU/Linux distribution, because he's quite proud of all of the GNU free software that is powering your computer. We could either call it GNU/Linux or realize that's being a bit pedantic and that this guy also picks stuff from between his toes and smells it. Yeah, you could really be very insistent, but then you're also a guy that picks stuff between your toes and smells it and eats it. What is, though, what you installed on your computer? You installed Ubuntu. The logo you probably have seen of it is on the right, and that's a Linux distribution. That is your Linux kernel on the one hand, and a bunch of programs around it. So that includes all of those GNU tools, the core utils, system admin stuff, stuff that lets you do users, passwords, etc. And then also usually a bunch of programs. So Linux came with, Ubuntu came with a graphics stuff, and so your login screen, and but it also came with Firefox installed probably, and some shell, and if you installed the full version, then also with LibreOffice and all sorts of other things. That is a Linux distribution. There's many of them. Ubuntu is probably the most popular one. And Ubuntu was free, but there's also many commercial ones. Red Hat Enterprise Linux is a very popular one. You cannot run that for free. You need to get a license with Red Hat, which is very expensive. Not per se cheaper than running Windows Enterprise versions. I mean, Enterprise, so you already know it's very expensive and that you probably have to do a lot of paperwork. But that is also an option. Companies run that because it's being supported for a very long time. You can install that and 10 years later still receive updates. And it's also, they want the actual support contracts that go with it. And many of these vendors have a desktop version, like you might have seen for Ubuntu. There was the desktop version which you installed in your VirtualBox or in your computer or whatever. There's also a server variant, so that's because a server, obviously, you probably most of the time you just interact with that remotely, and you don't have a keyboard connected to it or even a screen, so you won't need this graphics environment. Instead, it might come with a web server pre-installed or stuff like that. So that's why they have these variants. Ubuntu also has an IoT variant or whatever, but yeah. There's many of these distributions. So other ones you might have heard about or seen, or your fellow students have been bugging you to install over my stupid Ubuntu suggestion are so Debian, Arch Linux, Fedora are quite popular ones. Kali is one that's popular with hackers. CentOS is yet another one. But what's funny is that a lot of these have actually a shared parent. So Ubuntu is based on Debian. Kali is based on Ubuntu. Fedora is Red Hat Enterprise Linux, but then the free version without the support contracts and the very long support range. But if you run Red Hat Enterprise and are used to managing that for your company or something, you might install Fedora on your own laptop, get the newer versions of software, and but it isn't managed in much of the same way. CentOS is another variant of Red Hat Enterprise that is available for free. Both of these, for example, also sponsored by Red Hat, the company behind Red Hat Enterprise Linux. Debian, Ubuntu is being run by some other company than Debian. Kali is yet another company, a company that specializes in consulting services. Arch Linux is doing its own thing. But yeah, it's more or less they are mostly the same, but you'll find that some of the tools on them, for example, to manage your software on the computer, etc., are slightly different. and sometimes have a slightly different philosophy behind them. For example, Ubuntu is supposed to just work, and Debian is really on the free software front, and Kali comes with all of these hacking tools pre-installed. Yeah, Ubuntu is fine, and I chose Ubuntu because it's probably the most popular one. So that means that if you Google for "I have a problem Ubuntu," then you will probably find some answers somewhere. Yeah, if you are really a masochist, you could try installing Linux from scratch, and that really compiles everything and installs everything manually. It's more of a book than a Linux distribution. It's very educative, but I would not do that on a computer you might need to meet a deadline on. So that is what Linux is, and we are now going to switch to what's actually the meat of this presentation. So the shell. What is a shell? Well, it's just a program. We are going to be using bash, which in your computer you can find in the folder /bin/bash. I will explain a bit more about these folders later. Born again, because it's the improved version of the classic Bourne shell bin.sh, which is also available on most computers. Other ones exist, but we'll use the default for now. I assume it's the default on Ubuntu. I use a different shell program myself, with a bunch of plugins and stuff that makes it look nicer and view git statuses, etc. But they all more or less work the same, and I will be demonstrating stuff in Bash. At least that what all my screenshots are going to be from. But during the course, Hacking UC, you might see me use something else. So what is a shell? It's just a program to interact with your computer and all of the software on it. So not to be confused with the oil company, a shell here is a program that allows you to work with your computer. So your graphics interface is also such a program. The start menu on Windows also lets you interact with all sorts of programs, and it also allows you to launch things. You have the X button in the lower right, upper right corner, so you can close programs, open them, take screenshots, whatever. That is also a shell. But what people typically mean when they say a shell, that they mean a command line or a command line interface. And that's usually something like this. So this is what we usually call a prompt. You see here that you see my name, that's my username on the computer, and the name of my computer, and then the directory that I'm in. This is the home directory. And then it's basically waiting for me to type something in. There's also this stuff at the bottom, which you can just ignore. That's because of my fancy setup. So yeah, it's waiting for us to type something. So we can run programs in here. So then you just type the name of the program that's installed on your computer. In this case, I'm running the program Who Am I? And if I then press enter, you'll see that it provides the answer that my username is Tom. I might also provide options. So for example, I could type who am I -- help, and then you'll see that it's how to use it. It says here you type who am I and then the options you want to have. And this program has two options, namely doing the help and doing the version of the showing the version of the program and then exiting. So this program doesn't do much, but remembering that you can usually type -- help to get more to learn how to use a certain program can often be very helpful. It's also saying some more things about that you can find documentation somewhere. I find that info is usually not helpful. Instead, we can also get more help by typing man for manual and then whatever thing you want. So if we type man who am I, then we get the user manual for who am I. It says that it prints the effective user ID. We get the same output, etc. Typically, you find a lot more in the manual than you will find in --help. But yeah, who am I? So simple, it's not a big difference. So the manual is available for most programs, and it should be pre-installed on your computer. You use it just by typing man whatever. You can also get the manuals for the manual by typing man. And you can also just Google for things like man whatever, and then you can usually find the man page. So we also already saw one command, but we can also run many other things. I'm going to showcase a bunch of things now to show you how to get around a little bit. So we are starting out with where am I actually. So if I type pwd, I will get the current working directory. And that's very useful to figure out where you are sometimes in scripts. Then the next question you often have is what is here? So typing ls will show you what files are in a certain folder. Then you might need some more detail, and then you can type -l. As you provide this as an option to the ls program, and then you will get that ls will show you a lot more information. So what we are seeing here is a bunch of permissions. Who owns this file? So I made them, so I am the owner of them. What group owns these files? I'll get to that later. Some file sizes, well, these are two empty files, so yeah, they're empty. And then the date they were created, I think, or last accessed. I always forget which one of those is this. And this is often useful if you need to, for example, know who owns a certain file or something. You also have hidden files, and there you can provide ls-a for all or something like that. And you'll see here that there was a hidden file. It starts with a period. That's how you make a hidden file or a hidden folder in Linux or on Mac OS. And you will also see that we have here two special files, the dot and the dot. Dot is the current directory. So that is this directory temp test where we are in, and dot is the parent directory. And these are two important concepts to remember because they'll come back very soon when we are going to be changing directories. But that is, if you type -la, you will see that these two will show up. We also might do both these options. You can often combine many of these functions in many programs, and ls is no exception. If we type -l and -a, you'll see that we'll also see the details now for the .hidden file. And because typing ls -l space -a is a bit too much effort, and we're all about being efficient, we can also type -la. So all of these one letter, or most of these programs that accept one letter short options, you can combine those short options together, and then you will save some time. So yeah, this is -la with the abbreviated syntax for command line flags. So we might need to also move around. Say we want to get into a directory. Well, we are now in pwd, so we typed pwd, we are now in the temp/test folder. And there's a directory there that we can cd into, and cd is for change directory. cd, change directory. So then we can cd and then into the directory that we want to move into. And you'll see if once I type that pwd will also now say that you're now in /temp/test/directory. I might also want to leave this leave this directory and go back up to /temp/test. And how do you do that? Well, we saw that dot dot was the parent directory, and if you type cd dot dot, you will see that we go up. Again, pwd prints us our location in /temp/test/directory. Cd dot dot moves us up into the hierarchy. And we can also type more specified paths here, so we could also type cd/temp/test instead to move up, but that's a lot more effort. Most of the time you either want to move up or down, and then doing this using this dot dot thing is a lot more easy. There's a special shortcut that you can use if you want to get to your home directory, and that is just typing cd. And the home directory is, say, the my documents folder on Linux. And you will often need to get there, and if you just type cd, then you can get there much easier. What if we want to create a new folder? Well, we can do that using make directory, and you will see a theme emerge that there's usually some command that is much like usually it means more or less what you want to do. ls is short for list, mkdir is short for make a directory. Usually the arguments more or less make sense, so mkdir, and then you provide the name of your new directory and it will create that directory. You'll see that, yeah, we were in this directory, we made it, and now ls will also show that there is a directory there. So if you want to edit a file, create a new file called main.c, for example, or edit a file that already existed that was called main.c, we can use the program nano. That's an editor. There's many editors, and I'm not, okay, I do have a preference. I am not the biggest fan of nano myself, but it is a very easy one to use, so I'll demonstrate it here right now. But if you want, you can also use anything like VS Code or whatever, or Sublime Text. Vim comes with its own special set of instructions. Just use whatever you want, but gedit is also a good one. But for now, we'll stick to nano because it's a command line client. So, for example, you get an editor like this, and I just typed in this this hello world program. Very simple. You might have seen it before. It's just an int main. Yeah, get some arguments. We don't use them. We just put the string hello world. So you see this bunch of buttons here in the bottom. So you have this get help, write out, some search stuff, copy paste, whatever. So this caret thing means that we need to press the control key and then O if we want to save. So if we press control plus O, then you get, the file name that nano is supposed to write out. And then we can just type enter, and then it will say that we've written 5 lines to main.c. Then we can exit via control.x, and then it will have written this file, and we will return to our shell prompt. Then we go into, we want to see what was in main.c. So we could either open it up with nano again, but another way to do this is using the cut program. Cut is short for concatenate, because you can also use it to stick files together. But if you just provide one argument, then it will print out whatever that argument was, the contents of that file on your command line. So you see that I typed cut main.c, and then we provide with output here, and that is exactly the program that I just showed you. Searching is also something that's very useful. So grep is a program that is something with GNU regular expression. Pretty sure the R is for regular, and EP is something to do with expression. It allows you to search in files. So if I, for example, this example, I search for hello in the main.c. So yeah, this was the contents of main.c, and you see that this line has hello world, and we will get that line as output in in what we've, because that matches the pattern that we searched for. I've put the argument here in quotes. Note that these quotes were not matched because otherwise we wouldn't have found the result. These are just quotes that surround this argument. If you have a single argument that contains a space, you need these quotes around it, etc. We'll get to that. It is very powerful because you can use full regular expression syntax. Make sure to Google how that works because it's a slightly different syntax than you might be used to. You can also search recursively, count how many occurrences are. The manual is quite extensive. Google helps you a lot. Yeah, very powerful, very nice tool. Takes a little bit of getting used to, and it's especially useful in some cases that we'll get to soon. Finally, this overview cheat sheet thing is I'll show you how to compile a program. So you might have done this using whatever they use in programming in C nowadays, code blocks or whatever. Still, I don't know. Instead, we are just going to do it the manual way. So the GNU C compiler, GCC, and if we just provide it a C file, then it will compile it. By default, it will compile that to the very annoying file name a.out. It's not the best. I don't know why they chose that, but that's just what we get. You'll see that there was this was the contents of this folder. We compile gcc main.c, and you see that it creates a.out. If we want to do it slightly better, then these are the options you want to use. So we have here -w all, which turns on all warnings because we want our mistakes. GCC is very, very tolerant of mistakes, which is not usually the best because often that means that you made some programming error. But remember that I said this turns on all the errors? Well, actually not really. It turns on only a few. So we also enable -W extra for all of the extra warnings that we also want. And we provide this -O here. And that is a special argument. It gets an option that gets an argument. So -O is specify the output to, and then the file name of our out thing. So we don't get a.out, but instead the output will be an executable called output, and then the input file name. And you see here that using these warnings, now GCC is now starting to complain about these arguments that were unused, which is valid. I mean, they are not being used, so that could be an indicator that you are doing something stupid, because I could also have left them out. And then you can see here that we can run this program by typing /output. This / stuff is special, and that is because there's a special variable called path that specifies all of the locations where executables are. And unlike on Windows, the current directory is not in there. So your if you type so like how we typed ls here or gcc or whatever, all those programs are executables that are in one of these special folders that are on that list. If you want to run something that is not on that list, then we need to specify the path to that executable. Otherwise, it will take the name of the executable, go look it up in that list of folders where executables are allowed to be, and then will not find it or find some other program, and then run that instead or complain it couldn't find it. So we also always need to specify some path if a program is not in those special folders. And because in this case it isn't, we type dot for current folder and then slash as a separator for folder names and file names, and then the output directory. We also could have, because remember this was in the /temp/test folder, we could also have typed /temp/test/output, but typing / is a lot quicker. Yeah, that gets us to the exercise, but let me also show you a bunch of other nice tricks. I will set up my terminal for screen sharing if you give me a small moment here. Let me share this window. Oh. So, hello. This is a terminal window. It is very scary, but it does not bite. Actually, I'm not being a real hacker right now. Now I'm a real hacker. You see that this is a PWD. This is the tutorial, the Linux workshop folder of my hacking in C folder somewhere. And this is specifically the LaTeX source code for the presentation I was showing you earlier. There's a bunch of files here, as you can see. I can also see how large they are. This PDF is some amount of bytes, which is very large. Actually, let me type also -H, so it's H for human readable, and you'll see that it says the PDF is 3.6 megabytes large, probably due to all of those screenshots that are in there. I could do a bunch of things here, like PDF LaTeX, tutorial LaTeX to compile my tutorial file. And yeah, that's how you run things. It wrote the transcript to tutorial.log, and then yeah, you get pretty much the same thing. But typing tutorial all the time is of course super annoying, so I'm gonna teach you a special trick. If you type the first two letters and then or any amount of letters and then type tab, all the rest appears automatically, and it's in this case completed it up to the period, because that's when there are different files that have the same name. So now I need to, for example, I want a PDF, there's only one thing that starts with P, so I type tab again, and then it completes the file name. I can also do this when I'm moving around. So if we go to /etc, I press tab twice, and now it's showing me all of the options that were there. I can also move around that. There's a LibreOffice there, LibreOffice, and I can autocomplete that again, and then I move around there. /temp, ls. Clear is a command that allows you to reset your screen. I can create a new directory called workshop, move out of it again using cd .. Now I'm back in this /temp folder. Let's go back into workshop. And now I want to create a hello world file. Actually, I press Ctrl X to do this closing. I don't want to do that. I want to do a hello world.py. Let's write some Python. Print hello world. Yes, to hello world.py. Python hello world.py. Well, that was easy. There's many ways that you can run. I could type help, but that will be a bit annoying. Also, not even all of the stuff. The yeah, is there anything else I need to show you? Yeah, so cut does this. Could also do it twice, but then that's why it's called concatenate. If you provide more options, it'll just print them after each other. Yeah, so I have a brief exercise for you, and that is to open a terminal. So I hope you have your Ubuntu VM ready, and then to create a folder called workshop with the file in there called hello.c, and there you can write your best hello world program in C. I want you to compile it to a executable called hello, then rename that to hello world, run the program, and also make sure that there's no other files in the folder. And you might be thinking now, help, I don't know how to rename stuff because you didn't show that, Tom. That is correct. There's so much to explain to you about how all of this works that I also I'm just better served by teaching you how to Google things. So if you type, I want to rename a file in the terminal in Linux, then you will find a resource that will tell you how to do stuff very quickly. And of course, don't open the file browser thingy and F2 and change the file because that's cheating. I think that 5 minutes should be enough to do this and also allow people to refresh their coffee maybe. What time is it? 28, so let's be I'll show you how to do this in 35. So yeah. Actually, if there's also questions, I can answer them. What have people in Discord been doing? Oh yeah, of course. I didn't think about that. You need the slides to do something. Apologies. Um, yeah, if you don't know how to program in C, you are going to be a bit in trouble in this course. You don't need to do very complicated programs, but you do need to know how to, well, hello world is a good start. But with regards to that, you're free to cheat a hello world off of Google. That's fine. Yeah, you might have guessed that we were going to be doing some C programming, considering that the title of the course is Hacking in C. But I can answer questions about that also afterwards. Okay, I think that we can continue. So I will just slowly go through what the to-do was. Let's see, screen capture. And we can have both. So opening a terminal is easy. I did that. And yeah, so let's go to my home folder, pwd. And I'm creating a folder called workshop here. It's slightly glitchy in the recording, but I hope this is okay. Then we are creating a file. Hello, let's see. You could use nano. I'm going to use vim now. Well, we need the IO header, int main, put string, or printf. Many people like printf. Hello world, new line. Oh, and return 0. then we can compile this. So I could also have done this with nano, and then you would have typed this in and then typed write out hello.c with control.o, control plus O, and then we can close it using control X. We are now going to compile it. So gc -w all -w extra. There's many other things that we might need to do. Wait, how does this work again? I'm going to use mon gcc. GC is telling me that I can use GC and then -O for the output file. And then it has a bunch of other things that I'm not going to use. So GC W all W extra O to hello. And we are compiling hello.c. Enter. Okay. It didn't complain about any warning, so that's good. And I can type ls. Oh, I was being an idiot. I made this in my home folder instead of in the hello workshop folder. Let's move the files to the workshop folder. So hello and hello.c, and we want to move them into workshop. And again, this was one of the commands I didn't show you. mv is move, so I can just do that. cd workshop, and then I find here that there's no other files. Okay, I can now rename the file to hello world. And what is renaming? It's actually the same thing as moving things. So I can move the file hello to hello world in the same folder. And then I can type ls and then run hello world. There are no other files here. That is because I did not create any other files. But for example, if I type gc hello.c, and again I'm using tab here to autocomplete all of these things, then you will see that there's an a.out file that's not supposed to be there. And I can remove it using the rm command. Rm for remove, a.out, and you'll see that it's now disappeared. And yeah, so I told you that Googling all of this stuff is quite easy. We could also have typed rename a file in Linux. And then how to use the rename command on Linux? Well, it's just, we can just use mv. And it also tells you how to do stuff with for loops here, but that's all unnecessary. You could have just done this. You'll see that there's many tutorials. Delete a file, use the rm or unlink commands, blah. Oh, that is my mailbox. It's very easy to figure out stuff here. And I'm going to switch back to the slides because that renders a lot better. If there's questions, we might do them now or later. It's a bit hard for me to judge how many people have questions. Yeah. There are clearly questions in the Discord, though. Sudo is not what you need here. I'll get to sudo soon. You're running the text file without compiling it. So Todd forgot to run GCC on his hello world.c, and that will not create a binary out of it. So you cannot run the C file without compiling it. And yeah, this was not so correct. Putting sudo for basically any command is not what I would do. I think that Todd probably ran it without using type ls first, and your there's a bit of latency in this video stream, of course. So yeah, you have a hello world executable, and you're running hello world.c, and you should do it without sudo. You renamed your C file, and so what you did in your first command, if you go to the very first GCC in your screenshot, then you have -o output. So you created a file called output instead of hello, and then you use tab to autocomplete probably your hello, and then it made of it hello.c instead of your output file. It's I'm not trying to publicly shame here, but yeah, it's just what happened probably. Yeah, I think you got it. This kind of stuff happens all of the time, and it also happens to me all the time, and it's all completely fine, and you'll quickly learn how to solve this kind of stuff. It's also often no big deal. Typing sudo is probably not something you should try as a first solution, because that just elevates stuff to admin privileges, and it will not fix your underlying problem most of the time. Instead, you will run it as administrator and maybe remove your computer. It will also make stuff more complicated, because then, for example, if a file is being run as administrator and creates a new file's output, that will also be owned by admin. So then you can no longer use it as your normal user, etc., and just make stuff more and more and more complicated on your computer. Yeah, so that was what we did here. And let's move on to some special I/O stuff. So you saw that your program created output. That was what we did with printf or puts, or like you might have seen in the C++ course is cout. And then this ends up in the terminal. So also when I used cat file, it printed something out to my terminal. That is the standard output, or std out. And that's a sort of special file type thing, but just remember that standard output is std out. And we also have standard input. I should fix the title. And that's what the program reads in from the terminal. So if you use get_s or cin or readline or some other command, then you are reading input from the terminal into your program. I could also demonstrate that. I go to this terminal. If I type read, that's a program that blah. Then I can type something here, and now it said that the blah variable to this string that I input. This read thing just gets things on the input, and then you can have it do something with those. So that is standard input. What you type in here, so this is also standard input, but it's given to the shell program, is input. Let's go back to my slides. And then there's a special type of outputs called standard error, and that is error messages. It's printed out to standard output, and it's often mixed through it, and you normally don't see the difference, but you'll see that there is a difference in the next example that we're getting. So what we can do is take this output that's being output from your program and send it to some other place. And for example, we might want to save it to some file if we want to do a log or something, or create a new file using the output of a program or something like that. So in this example, I'm in this folder where we have main.c, and it has these contents, and I want to take the output of this cat and create a new file. So the file didn't exist before, what I can do is cut main.c and then this arrow and send it to file. And that creates file, or if file already existed, it empties it, truncates it, and then writes it. So this will also overwrite an already existing file. I could also append something to a file. So you see here that I first truncate file and put the contents of main.c in there. And then I can also do that again. But if I use the double arrow here, then we will get it concatenated. So you'll see that it's in here twice now. This seems a bit useful, maybe useless, maybe, because this is just copying something, and you could have also just used the cp command for copy, probably a lot more efficiently as well. But this is often useful for if I want to get some output from somewhere and then save it for a more complicated command. For example, if I want to save all of my compiler warnings or something. The reverse you can also do. So you can also take a file and give it as input, standard input, to a program. So this captured your standard output and sent it to file. But we can also take a file and give it as input to our program. And that we do with the arrow in the other direction. So if I take my tutorial file and want to search who the author is, I can use grep to search. And I use this arrow to provide this file's input to grep. And then it will find out that the author is Tom Wiggers. So if you paid attention, then you know that grep also takes a file name as an argument. And in this case, I just decided to provide the input in another way. This again is sometimes useful, not always useful, but it's especially useful for commands that usually take programs that take input on standard input and then provide it from some file instead. Well, we can now take output from programs and send it to files, and take files and send them to programs. But can we also send output from one program as the input to another program? Of course we can do that. So we can also redirect the output from one program to another program. So in this example, we have curl. That's a program that downloads a web page and then just outputs it. So I can, where is my terminal? Curl downloads a redirection because Thalia.nu is on an HTTPS website. In the slides, I have here that we download the correct location of Thalia's website, and then we want to know if there's a boggle. And unfortunately, right now there are no boggles, so we don't get any output from grep. But interestingly, we still see this output here, which clearly does not match the word borrow. And that is because this output was sent to standard error instead of standard out. So this is the type of informational message that gets sent to standard error instead of the standard output. And in this case, that was the how much time it took to download the source, the web page, how many bytes it was, etc. Yeah, so that's the output input redirection thing. It's done using this vertical line character. It's above my enter key in my keyboard, and it's called a pipe. So it's also called piping output from one program to another. I could also provide another example of this. terminal. So cut hello.c grep hello would again find this hello world line, or we can also use wc for word count, and then we want to see how many lines we have, and then we see that this program has 6 lines. We could also have done this using hello c, but sometimes you have a command that it doesn't have a file. So if you want to see how many lines the Thalia website is, or how many characters, minus c for characters, then we see that it is let's try this again, that many characters. So these pipes can be very powerful to send output from one program to another and then just do whatever with it. And you can also often send grep, what shall we grep for? Corona. Okay, that didn't work. Cancel. And then also try to see how many characters this line is, and then we'll see that the output of this grep command, which was this line, it gets mixed in with the standard error, unfortunately. We can send that on to word count, which in this case counts the number of characters. Going back to my slides. Then we have some system admin stuff left. So let's first start with how your system looks like. So Linux is, Unix in general, is very file system oriented. And we have, obviously, you most of the time are running programs which are files or doing operations on things that are files. And that's why we have a file system. And it starts with the slash folder, which is the root folder. And then we also have slash boot in there that contains the bootloader. And then we have slash bin. That is a folder where you can find a lot of binaries, bin for binaries. Then there's sbin, that's the super users slash bin. There's also some special device handling stuff that goes through the file system. You usually don't need to do stuff there, but you might find your hard drive there or something in slash dev. In slash etc. there is the system configuration. The slash home folder will contain users' home folders. If you have more than one user, then you will find more users there. Slash root is on a separate location. The home folder of the root user, that's the administrator. And then there's some other folder, so the lib or the user, var temporary files in slash temp, which disappears on reboot, useful to mess around in. And that's just a bunch of the folders that you have on your system and that you might need to go into at some point. So folders and files have an owner and they have a group. I already briefly touched on that in the ls segment, and they have an owner and a group, and there's a bunch of groups and a bunch of owners. Well, the owners are just usernames and the groups are special group names, and that is because you can usually set settings so that if you have a group called students and then a bunch of your usernames are a member of the group students, then they can all access files that are owned by the group students in a certain way. And that's done through of these permission levels. And then what's the owning user can do, what can the group members do, and what can anyone else, so others, do. And then you have the permissions of read, write, and execute, RWX. And ls-l shows this information. So here we have that in directory. is read, write, and execute for myself. Anyone in the group Tom, there's also a group Tom where I am the only member of currently, where anyone in that group can read it and can execute it. To list the files in the directory, you need to be able to execute it. Don't ask me why. And anyone else can also read and execute it. This file here, anyone can read it. I can read and write. Anyone in the group, Tom, can read it. Anyone else can also read it. And this output thing was an executable, and that has the X set, so anyone can run it. Yeah. You can change these permissions using change mode or change owner. Use the Googles. Oh no, I have examples actually. So shown change owner can make some other user own a file. You usually need to be admin to do that. Change group, allow someone else, another group to exit. The D at the start, that is for this is a directory. Good question. And indeed it is directory. Might also want to change permissions. So for example, set file to be executable for the user. Then you can type u plus x and then the file, or make it writable for a group, or take all of the permissions away from others, and then you can use that through these ways. There's also numeric ways of representing this. It's a octet where this is 4, 2, and 1, and then people add that up, and then you get 7 if you have all the permissions, but this is much more readable. But you might find it the other way sometimes. So sudo, that is super user do. That runs a specified command as root, and you need to be in a special list to do so, and your default user on your VM will be on that list because Ubuntu is set up that way. If you run sudo on a CNCZ owned machine, they will get an email saying you've been naughty. And they might actually send you an email asking what the hell were you doing. That is because you were not on that list if you run something on a CNCZ system. So if you see here that I run sudo who am I, then it asks me to enter my password, and then you see that I suddenly am the root user. So root is the super administrator on your Linux machine, and root can access anything, can read anything, can write anything, and unless you're doing system admin stuff like installing a program or something, you should probably usually not run it as root. But it is useful, for example, if you want to install programs. So that you might do through the program called apt. The tutorial already briefly used that. If you run on Ubuntu, then you can use apt as the I'm actually not sure what it stands for, but probably application something, and you can use it to, it has a cache of all of the packages that are available and the versions, so you need to run apt updates once in a while, and I think Ubuntu does that in the background by default, to update this index, and then you can search for applications. If you want to install something, then type apt install application name, run apt upgrade to install all of the upgrade all the things you have installed. And this is one of the things, these package managers make your system administration so much easier than on Windows, because I can just type apt upgrade and then everything is up to date. Instead of going to the Discord website to download the latest version, I can just type apt upgrade and everything is updated. So that is something I like very much. And if you run apt install and you're not root, then you will get a complaint you don't have permissions to do this, and then you type sudo in front of it, and then it does work. And that is because for this type of stuff, you do need to be the root user. Yeah, so apt is a Debian thing. Debian and Ubuntu and Kali and a bunch of other things. Ubuntu has a bunch of variants. They all use apt. If you use something else like Fedora, then you might need to use yum, or on Arch Linux you need pacman. There's equivalents everywhere, and you are often best served by the manual for your distribution if you need to install something. If you want to install something on Linux, if you're used to Windows and then going on the website of that software and downloading some package and then double clicking it and going through a wizard, try to wean yourself off that for Linux and use these package managers, because they can keep everything up to date for you. That brings us to the end almost, and we're already doing this for way too long, so I'll keep it short. Vim. And if someone didn't tell you already that you should try Vim, there will be some smarty pants at some point that will tell you that you should really try Vim, and the first hit is free. Know what you're getting into. It's a super powerful editor, but it's very complicated to use because it has a very weird model behind it. Instead of what you're probably used to, where you can just type stuff, because it's a text editor, and then there's a box where you can click on, and then you can just type stuff. It has stuff with modes and regular expressions and weird hotkeys, and typically people get confused and then they try to exit it and then they cut. This is why exiting Vim is such a meme. If you want to learn it, that's fine. I have a bunch of links here for you. If you don't, stick to Nano, use gedit instead, and be more productive quicker. Vim Tutor is nice. There's also this really nice game that teaches you how to do stuff in Vim, though you need to pay after a while. MIT has a tutorial on using Vim, but yeah, other editors are fine. You will see me using Vim because I like it, but I already invested that time. Don't come to me that you haven't finished your Hacking in C assignment because you got stuck in Vim. Okay? Yeah, so there's this nice webpage where people make memes about how to exit Vim. Oh, very nice. Yeah, of course, people are making jokes here. Vim can run all sorts of commands, and you can also then use the operating system to kill Vim. Yeah, memes. So this presentation is on my website. God damn it. The slides are here. If you go to my website, teaching 2019-2020, shell tutorial. I will also put them on Brightspace. An alternative tutorial that goes a bit further is the MIT's is doing some stuff online somewhere. Seemed nice. I haven't looked at it too much, but they also seem to cover a little bit of shell scripting. And I think that that will be it for now. It should be enough to get you at least not stuck in your home folder the first time you open the shell soon. And yeah, I think that that is it for now. So, do people have questions? Curl might not be installed by default indeed. Then you can type sudo apt install curl, and then yeah, that is a tool that I always install so early that I forget it might not be installed by default. Yeah, Tol asking, well, we should know how to use C. You will not need to write programs yourself. So the exercises are often, you are provided with a C source file, and then often need to break it somehow. And typically you can do that easy enough by figuring out what is going on from the command line, command names, and a bit of Google. So it is quite similar to what you're doing in C++. And because you don't need to do the logic work, I would say, I think that for most people it's very not too much of a step to move to C instead of the ++ part. You don't have the stream stuff in C++ in C like you had in C++. So that cout cin is now printf, getS, other commands. But that's all not too complicated. And we'll also cover a bit of that transition in the course itself. Yeah, I am aware that you had C++ instead of C, but don't worry too much about that. You saw that it did not look that much different, right? Yeah. Any other questions? When will the course start? I think more or less the same. So I reread the announcement by the university on what we're going to do next quarter. They said something about the first week of April. They hope to provide more clarity. I hope that they will do that slightly better than what they did for the exams of the next period, because they promised you that you would get an answer by yesterday from your teachers, but then the university only decided what to do at 7 p.m. in the evening. This situation is also for us a bit unclear, and I will try to do the best I can, and probably will be doing stuff in a similar way during the course. So doing live streaming. I'm not sure if I will do as big 2-hour lectures, or maybe break it up a bit more, or create short clips. I'm also hoping to get a lot of feedback from you guys, because I'm also just figuring this out as we go along, as well as all of my coworkers. The education department is now discussing if we need to purchase Zoom or whatever for things, and it's a big mess. University IT has no idea what they're doing, because the university router cannot deal with this traffic that they're now getting. It's also just we're trying our best. I think that I will, for the most part, probably be sticking to the usual schedule. So that means that I will still be getting stuff on giving some form of instruction in a sort of lecture setting, maybe break it up a bit more. And I will still be probably be running tutorial sessions in the way, but there will be so of course there were lab sessions, so people would get into a room with computers and there will be teaching assistants running around, student assistants who would help you if you had questions where you could put your hand up, etc. And we might need to do that on Discord instead, for example. You can do screen sharing there, then your TAs can do voice chat with people, and that's the kind of stuff that we will probably be doing. But we're not going to be doing that 24/7. I cannot ask that from my teaching assistant, so there will probably be also still a time slot, and then except for it being in a specific room in the Huiges building, we will be doing it online instead. I will also definitely be sending email about what exactly is going to happen, etc., in advance of the first lecture, obviously. And also the first lecture will contain probably a bit of intro and explanation of what I'm going to do. Yeah, it's all a bit, yeah, figuring out things, of course. This streaming setup I'm quite happy with. It seems to work quite okay. Switching screens is a bit of a hassle sometimes, but I think it works for the most part. And yeah, it's convenient that YouTube puts it online for me immediately. And yeah, I'm not sure if this Discord Nitro really adds something except for emoji. So yeah, I'll think about that at some other point in time. Yeah. And I think that for the most part, I don't think the quarter will start before it used to start. So it will still be, I think, April 15 or something like that when the first lectures were supposed to be. Yeah, so April 13 is the second day of Easter. I think that the first lecture was scheduled for April 14. And that will probably still be the same. And I would appreciate it if people don't all postpone doing everything until the last possible moment, which I realize is possible because everything will be online and you can view it at any time of the day. But I'm not sure if binge watching is the best approach for doing lectures. Yeah, and with that, I think that I am done. So if people don't have any more questions, then I will log off for now. And maybe if anyone has a question during chat, they can just type it in the Discord chat and I can answer it there. Stay safe and don't forget to like and subscribe.